So in this video, I'm going to remind you how we can find percentages, specifically using multipliers. The huge advantage of using multipliers to find percentages is that the thing that we're finding percentages of need not be numbers. We can actually just as well use multipliers and create algebraic expressions. That's exactly what we're going to do here. And when we do that, we're working with something called generalized percentages. Okay, let's have a look at the first question here then. So if I wanted to work out 14% of 350, you have quite a few ways you could do it, but if we were using multipliers, we would say that 14% as a decimal is 0.14. So I could write that as 0.14 of means multiply, and then the number there is 350, and I could carry on. I can get my calculator if you like and actually do 0.14 times 350, and we'll get an answer. In this case it's 49. Fascinating. But importantly there, that number there, that 0.14, we call that the multiplier for finding 14%. Now the reason that's important is because I can just as well work out what 38% of x is if I want to, because I can just use a multiplier. Now the multiplier for 38% is 0.38, just the same as the decimal representation of 38%. So I can just do 0.38 multiplied by x, and the way you would typically write that is without the times sign. So the answer is just this expression 0.38. X. There are a number of other ways you could express that if you wanted to. There's no reason why you couldn't write that as a fraction instead. So that's 38 out of 100. I'm not saying you have to, but you could do it. So it could be 38 hundredths of an x. You could simplify that's 19 out of 50. You could multiply those together. If you think of it as a fraction, if you think of it as 19 over 50 times by x over 1, you could call that 19x over 50. All of these are the same thing. Okay, I think most of the time we'd be going for that as the answer. That if you want to do 38% of x, then you get 0.38x. I think that's the one that we'll use most of the time. But all of these are true as well. There's no reason why you couldn't express it as a fraction if you so wished. Y% of 60, that's a little bit harder to think about. Now, how do you do a percentage? Well, Y% is y out of 100. So I could use a fraction to help me here. This is y out of 100 of means times 60. I can then think of this as multiplying fractions. So I represent 60 as 60 over 1. And what have I got on the top? I've got 60y on the top and 100 on the bottom. And we can simplify that a number of ways if you wanted. So 60 out of 100 is 6/10 or 3/5. So we call it 3y over 5, or 3/5 of a y. That could also be 0.6. We call this 0.6y if we want to. Okay, notice that y% of 60 is the same as 60% of y. Okay, same thing. Oh, in fact, if you hadn't noticed that before, all percentages are reversible. So if I'd done 350% of 14, I'd have got 49 as well. So all percentages can be reversed. But that's a nice little demonstration there that y% of 60, well, y% is just y out of 100. When you multiply them together, you get that fraction there. You can simplify 60 out of 100 if you really want to be 0.6. That's the same as if you were doing 60% of y. Okay, here's some more examples then. Suppose I wanted to do A% of B. Well, I'll use the same method that I used before. We'll say that A is A out of 100. Of means times, and we call B over 1. So it's just AB over 100. There's not a lot more. I call it 0.01 AB, I suppose, if you want to. 0.01 AB, because 1/100th is 0.01. So any of these are fine. That one or that one could be considered the answer to working out A% of B. I'm now getting to the more important bit. These are going to be expressions for an increase or a decrease. If I want to increase a number, it doesn't really matter what that number there is, but suppose I want to do an increase of 12%. The method you learn to make a multiplier, where you say, well, okay, you start with 100%. If you've already got 100% and you add another 12%, 100 plus 12 is 112%. So I could just put this in brackets of you've already got 100%, you're going to add increase by another 12%. That gives you 112%. So this is a bit like saying work out 112% of 20. Okay, it's the same, exactly the same question if you think about it. Increase something by 12% is the same as finding 112% of that number. For this particular question, it would be 112% of 20. That number there as a decimal or a multiplier is 1.12. Okay, I wonder if I can do that in my head. That's going to be 22.4, I think, without a calculator. Check it on a calculator, I probably got it wrong, but there we go. But that's the idea, isn't it? To get an increase multiplier, you have to add it to 100. So it wasn't just find 12%, it was increased by 12%. Therefore, it's 112%, and it's not 0.12, it's 1.12. Okay, that should be familiar. You would have done that in year 7 and year 8 as using multipliers to find percentages. Now that I realise, now I know how you do that, I can apply it over here. An increase of 9%, well, 100 plus 9 is 109. I'm basically finding 109%. 109% of P. I can put that in brackets if you like that. So I started with 100%, I added another 9%. That's 109%. So the question is basically saying find 109% of P. So that'd be 1.09 times P. 1.09p could be considered my final answer. You can express that lots of other ways with fractions and so on, but let's stick with that one. It's probably the simplest way of doing it. Decreases are very similar, but this time if you start with 100%, you're going to take off that bit there. So to decrease something by 10% is the same as just working out 90%. Okay, I'll let that sink in for a moment. To decrease anything, in this case 30, but to decrease anything by 10%, you could just find 90% of it. Okay, and 90% is, 10% less than all of it, isn't it? That 90 there I've got by saying you start with all of it. It's a decrease on taking off 10%. That leaves me with only 90%. Now you know the multiplier for 90% is 0.9, so I could do this question by doing 0.9 times 30, and again, don't need a calculator for that. I can do that in my head. That's 27. Because the question had entirely numbers, I've got an entirely numerical answer. Over here, there's a letter in the question, so I won't have a number as my final answer. I'll have an expression, an algebraic expression as my final answer. Now, a decrease of 20%, if you start with 100, you can do this bit in your head, but I'm writing it out for the purposes of the video. Decrease by 20, take off the 20%. So you start with 100, you'll be left with... Sorry, start with 100, take off 20, you'll be left with 80. That's right. So decreasing anything by 20% is the same as just working out 80% of it. Okay, to decrease anything by 20%, just work out 80% of it. Now we know that 80% as a multiplier is 0.8, so I could write this as 0.8 times k, and then I can say, well, that's just 0.8k. Lots of other ways you could write this. 0.8 is the same as 8/10 or 4/5, so we could say the answer is 4/5 of a k or 4k on 5. Lots of alternative ways of writing it, and sometimes the fraction might be more useful than the one that has a decimal in it, or it depends on the situation you're trying to solve. Now, finally, suppose I had a statement that looks like this. This is really what your questions will look like. You will have lots of questions which are very similar to this to work with. So I had to build up to it to sort of make it obvious how you do. If I dive straight in with how this works, it's probably a little bit too complicated. But hopefully now you've seen the background is not too bad. This statement here will allow me to write an equation. Once I've got the equation, I could do quite a lot of things with it. Notice how I'm not actually asking you a question here. I'm just making a statement. You will have specific questions. It might be, therefore, find the ratio A to B, or therefore find how many B's go into A. You might have a very specific question. What fraction of A is B? You might have a very specific thing that you're trying to find. I haven't written a question here. I've just written a statement. I'll show you the sorts of things you could do with a statement like this. So A increased by 40%. Let's think of that first of all as one object. Well, to increase something by 40%, that's going to use the multiplier 1.4 because all of it, 100%, add another 40 is 140, and 140% as a decimal is 1.4. So I could say that's 1.4 lots of A, with or without the times sign, is the same as, well, that's an equals sign, isn't it? That just means equals. And 70% of B, well, I'm going to use my multiplier. I'm going to call that 0.7. Okay, that's allowed me to write this equation. I'll just squidge it up and dump the times sign. So we've established that 1.4a is the same as 0.7b. Lots of things you could do with this. I could tidy this equation up, make it simpler by doing things like multiply by 10. If I times both sides by 10, that helps because it gets rid of the decimal. So multiplying both sides by 10 would tell me that 14a is the same as 7b. You might notice there's a common factor of 7, so you could divide both sides by 7. That would be 2a equals 1b. All of these things say the same thing. This English sentence, this, these all say exactly the same thing. They're just different ways of representing the same information. And I think this is probably the easiest way so far. I might want you to write this as a ratio. Now, I don't know what the numbers a and b actually are. No idea what the numbers a and b are, but I can tell you that they're in the ratio 1 to 2. Okay, you have to double the a number to get the b number. For example, a could be 50 and b could be 100. A could be 6 and b could be 12. So it's in the ratio 1 to 2. So this sentence could have led to that ratio. You could say things like A is 50% of B. Okay, which if you think about it, it's got to be true, isn't it? I mean, maybe it's easier if I halve both sides of this first. If I divide both sides by 2, that would give me 1A equals half of B. So I'm literally saying A is 50% of B. I'm just trying to show you there's lots of different ways you could re-express the same thing, and depending on the question, you might need to do one or more of these things. A question may require percentages, it may require ratios, it probably just requires making an equation, but it really does depend on the situation. Hopefully those skills are enough to get you a bit further on the worksheet. Good luck.